As I said in the beginning, we are going to have a discussion with the audience. So I expect that many questions are... hello. No problem. So we are going to start, but as I was saying, we want to have a discussion, an active discussion with the audience. So I invite you to join more here in front in order the questions be easier, because we want we must have the micros for the streaming. So welcome to this cloud computing panel discussion. My name is Lígia Ribeiro. I am from the University of Porto, and I am also here representing UNIS, the European University Information System Association. So it's my pleasure and privilege to moderate this panel, and allow me to begin introducing the panelists. George Cortell is at my right. You already heard George at the plenary, the open session. George Cortell is president of the Oxford University Society Valencia and CEO and president of Cantron Systems. He has a background in business management and computing, and a large experience both in academy and in industry. Thank you for being with us. Paul Watson already spoke at this conference, also at the plenary session, bad clouds, good clouds. And Paul Watson is a professor of computer science and director of the North-East Regional eScience Center at Newcastle University. He is lecturing at the Newcastle University. He is involved in many big projects in Newcastle, and he has also a large experience in large-scale distributed computing, and also experience with industry. And we have at this panel also Christoph Witzig. Christoph is the head of the Switch middleware group at Switch. He has a background in high energy physics, and he worked at CERN when doing his PhD, and he's also large experience in this area of large-scale distributed computing, in particular grid computing, and also experience with the industry. So in this panel, we are going to discuss this cloud computing paradigm, and you know that this subject is now receiving a lot of attention, both from the academia and also from industry. There are lots of IT conferences that are addressing this subject, and this subject raises a lot of different questions, not only technical questions, but also, for instance, organizational questions. Are, for instance, the universities going to offer IT services the same way they are doing at this moment? Are the people involved in IT have different roles in the near future. And of course, there are other issues like financing issues, sociological issues. So we have a lot to discuss. And I perhaps suggest, as there are so many views of what is really cloud computing, I would like to begin clarifying some of these concepts. So I would like to ask our panelists what are the views, their views in terms of what is the definition, how do you see cloud computing, and also if cloud computing is really a new thing, it's a revolution, or is just an evolution? How is it related to grid computing, to high-performance computing? So we will start with these two questions, and then the debate will be open to the audience, and I expect many questions in these areas. And thank you again for being with us, and on behalf of the TNC, I would like to thank you for accepting this invitation. Thank you.
Thanks for inviting me to be part of this panel. And first of all, I'm deeply sorry for the delay. It won't happen again, especially since I'm not talking again. Well, on the issue of what is cloud computing, I hate definitions, and especially definitions of something that is happening right now and might be evolving. So, but we all know the basic common characteristics. It's a resource. It can be seen as a resource that is scalable, a resource that is distributed, sometimes is virtualized, a resource that is accessible via software. There are some characteristics, but I think even more important than what's cloud computing, because we all have some of a fuzzy idea of what that is, it's more of an issue of what does it mean, if it's a revolution or if it's an evolution. I think that's a really interesting question. From my point of view, it's more of an evolution than a revolution, but at the same time, it's an important one. And it's not, I don't see it as a technical or technological issue, as a matter of fact, because just about all of the characteristics and all of the elements of that cloud computing were already there. So it's not that something came up. It's just the way we use it, is the way we interact with it, is what we do with those resources that is really meant something. And that's where the issues lay. Some are ethical, some are legal, some are economical. There are many aspects, and I think it's better to listen to what people want to ask and how they want to direct this discussion. But I will say that some issues got to be resolved before we take cloud computing really seriously. We make heavy use of it because there are some things I don't see clear, and unless those things are addressed, it's more of a threat or a risk rather than an opportunity. Those issues mainly being the user agreements, the standards, the interconnection, the data migration, the formats, interoperability, all those issues I think should come first. Then we can talk technology, then we can talk uses, but I think those issues are foremost really important and urgent, and I think from my point of view that's what I would like to focus the debate on. But then again, really willing to listen to what everybody's got to say. So.
Hello. Is this going?
If not, you can use this one.
Okay, so I use this one.
I think not.
Okay. Well, when I was told that the first question would be the definition of cloud computing, I went, of course, I did what most of us would do. You go up on the internet and you Google a bit, and you see with which definition you come up that explains you something. So the one that I particularly liked is from Gartner, and it says, I got it in an article, it's a delivery. Okay, so it's the delivery of massively scalable capability delivered as a service to external customers using internet technologies. Now, what can you take out of this definition? Well, if you look at the keywords, the first one certainly is massively scalable capabilities. That means hardware, software, applications, CPU power, storage. Then, of course, the massively scalable is a key word. And, of course, you immediately think of these huge data centers where you can fire up hundreds or thousands of virtual machines. And here is, I think, another key component, which is, in my view, a key prerequisite for cloud computing. It's the virtualization. And finally, also, it leads to these economies of scales that people talk to, that they can not achieve otherwise, or they claim they cannot achieve it otherwise. The other keyword that is in there as a service, and of course that's another buzzword. Finally, external customers, and I think that sort of points to also money issues, that people pay for it as a service. And internet technology, obviously you need a link between the user and the resource may be very far away. I think it's also remarkable what's missing in that definition. Well, first of all, normally in cloud computing one talks about one resource provider, not many resource providers. There's no mentioning of any standards or interoperability here, and it speaks of customers, not scientific or e-science communities. So that's also not in there. And of course, when I hear that, then I think of all the federated identities of the PKI mechanisms we have, and that's obviously there, all missing. And finally, also security is not in the definition. Now, I'm not saying these are all things that are missing out of cloud computing completely, or they cannot be implemented, but I felt it was interesting that at least in this definition they're missing. And that leads me to a second definition, which is a bit shorter, and it's also overly simplified, and maybe some of you want to pick it up. Cloud computing is the grid computing without the concept of virtual organizations. To the question of the history of cloud computing, I think here it depends on the time scale you're thinking of. And I can sort of imagine in computing one has three time scales. The first one is sort of the enthusiasm of the developer and of the PR industry, and that's a very short time scale, and in that sense cloud computing has a very, very short history. The second one is obviously the time it takes to develop code and to deploy it initially, and that's typically longer. Here we're talking months or a year or two. And finally, the last one is an operational of a service, and here we're talking years, and that's, I think, an area where many people here in the audience in NRENs have a lot of experience. So in that sense, I think, as I said, in the first sense, it's something very new, but I think one can also take the view of looking at it as a service, and then the thing that immediately comes in mind to me is it could be as old as 1972. That's when IBM announced the VM360 system, which basically gave users on a mainframe, not on a data center, but on a mainframe, the view of a virtual machine. There's also a nice quote, and I'm going to close with that, from Larry Ellison, somebody who's very infamously famous. And he said, the interesting thing about cloud computing is that we have redefined cloud computing to include everything that we already do. I don't understand what we would do differently in the light of cloud computing other than change the wording of some of our ads. And I quoted that from, it's quoted from an article above the clouds, the Berkeley view of cloud computing.
Okay, so when I give my talk yesterday, I said something that Christoph said, which is that there's so many different definitions you could find, and I think I'm comfortable with the ones that have already been given. I give one yesterday from Irving Vladsky-Berger, and that seems to capture what Christoph's just said. I think it's perhaps more interesting to think about what's novel about it, what's interesting about it, and personally, I don't think technically there's anything particularly new or novel about cloud computing. If you look at something like the Amazon cloud, then it's a bit like having a big cluster that's available to you. So technically, we're used to these sorts of systems, and going back through the generations. As Leisure said, I used to work for a company called ICL, no longer with us, but it used to be a big British computer company up till the early 1990s. And every time when somebody like myself came up with what we thought was a new idea, somebody in the company would say, oh yes, we did that in 1963 and it was in this particular model. And I'm thinking back now to the mainframes with the VMs that's already been mentioned, and the computer bureau that were around in those years where you could outsource your applications to these bureaux. So is there anything interesting about it? Well, I think what's interesting is the new business model, which is the reason why we should take it seriously. So the fact that there's companies out there who will give us access to very large compute resources for most organizations, not for the people at CERN doing the LHC, but for most organizations around the world, the sort of resources you can just go and grab in a second from Google, Amazon, Microsoft are easily enough to cover all of their requirements. So people say that effectively there's infinite resources available, which just means there's more resources than you could ever possibly need at any one time. And then the fact that you can grab them without having any long-term relationship with the company who provides them, that's a real difference. So in the past, if you wanted to use resources outside your own organisation, you would go and talk to salespeople and come up with a deal, and you would have some sort of contract which would talk about how many months or years you're going to have these machines for. And it's just not like that. You can just go out and grab them immediately. A friend of mine in Newcastle told me, who owns a company, was telling me about how he started to use cloud computing. And it was that he was sitting on the sofa at home with his girlfriend, and his girlfriend was watching Big Brother, which he decided was very boring. And so he picked up his laptop. So he's a proper geek. So he always, even when he's at home sitting on the sofa, he's always got his laptop next to him. And he picked it up and he decided he would try cloud computing, in his case Amazon. So he just went out and from his laptop he connected up, typed in his credit card number, registered. Within a minute, he was starting to use the Amazon cloud to do some of the work. He got interested in it. Within a couple of weeks, he'd moved all of his company's computing over to the Amazon cloud and stopped using the internal resources within his company. And so it's this ability just to go and grab these resources immediately. And then the final thing, I think, is the pay-as-you-go nature of it. So you grab these resources for a short period of time as you need, and you pay for what you use. So you grab them, use them, pay for them, and obviously you have to remember to give them up once you finish doing whatever it was that you needed to do. And again, that's quite a novel business model. And so these changes at that sort of the relationship that we have as users with the providers of compute resources, I think, is very interesting and new. And what's happened is this has created a lot of commercial interest. So I think this is the second broad reason why what we have now is new and different. So we're starting to see an ecosystem building up on top of these clouds, because commercial providers are interested in, firstly, the opportunities to build new software, for example, new software tools. I don't know whether any of you have seen, there's a company called 3Terra who produce a system where you go on the web and you use a tool where you create a distributed system, so you can drag web servers and drag routers and databases and so on. And you build your system, and then you just press a button, go, and it automatically deploys it on on an external cloud. And that's not produced by any one of the cloud providers. That's a company seeing an opportunity to build tools and to provide them to external users. And then you start to see the producers of middleware making available versions of their software already pre-configured in the cloud. So Larry Ellison, for example, his company now produces already deployed virtual machines in Amazon, so that if you wanted to take a database, you can just grab one of these, configure it, and use it. You don't have to start from scratch with downloading the software and loading it onto your own servers and dealing with it there. So we're getting this ecosystem, which is always, I think, healthy in computing. So it's not just one company that we're relying on, it's the base companies who are producing the clouds, and then the companies above who are starting to produce tools and applications. So I think this is what's different, the fact that commercial companies are providing resources on a pay-as-you-go basis, and then other commercial companies are starting to build tools and applications on top of that. And thinking back to the grid days, this is perhaps one of the problems with the grid, that we never really managed to get the commercial providers interested to the extent that they were devoting their own resources, which are of course larger than resources that the academic community have available, to providing this software ecosystem that we could then leverage in our own scientific work.
So from these first comments of the panelists, I think there are several questions, several issues that can be raised. And as I said in the beginning, this is a debate, so I will ask the audience if they want to present some questions to the panelists. Yes.
Okay, I just make some summary, but not serious, from what was a definition of cloud computing. It's like cloud computing is an old business model to sell new goods, such as computer power over internet, but using bad and good experience of grid computing. So actually cloud computing, what do you see that there is some relation between development of grid and that cloud computing became so hype in recent years?
You want to address this question?
I'm happy to.
Okay.
Just start. So I always find it interesting to answer questions about how grid computing relates to cloud computing, because there's no clear agreed definition of grid computing and there's no clear agreed definition of cloud computing. So comparing them is always quite an interesting challenge. I think that if you look at cloud computing as it's typically used at the moment, then it's not really like grid computing. So if you, let's say, you just use one particular cloud provider, which is mainly what people are doing at the moment, and they're running all of their systems within the cloud, so on Amazon or Microsoft or Google, then it's more like having a big cluster that you can dynamically allocate resources to than it is to grids. And that's one of the reasons why I think cloud computing has taken off, and it's been relatively easy for people to build applications in there, because a lot of the things that grid computing worried about, we don't worry about in cloud computing if we just use one cloud provider. Because grid computing, so I've said it's hard to get a definition of grid computing, so I'm now about to give one. Grid computing, a lot of it was about virtual organization, so combining resources that were under different management control. So I might have a cluster, you might have a supercomputer, somebody else has some data on a disk farm, and somebody else over there has a virtual reality suite. And we want to understand how we can combine all of these resources together in order to achieve some sort of scientific result. And that requires us to deal with difficult issues such as how do we have a security model which overlays these different providers of resources, given that they might internally all have different security systems. How do we transfer data around? How do we transfer work around? So that was the Foster and Kesselman-Tiki definition of grid computing as forming virtual organizations. And so if you compare that with clouds, and most cloud applications at the moment aren't trying to do that because they're just within one organization, they're just within one cloud. So a lot of those issues go away. Now, I think one thing that's interesting is that there's starting to be people who are thinking about using clouds as part of distributed systems. So they're thinking about, well, what I'd like to do is I'd like to be able to use my own internal resources, say, within my organization, and then if they aren't able to cope with an increase in demand, then I will do what's often called cloud bursting. So I'll start to send work out to an external cloud. And so then you've now got you're now trying to form a virtual organization for your application with your own organization as being one node in that and a cloud provider as being the second node. And immediately you then get into all of the issues that grid computing had to try and understand. So how do we have a security model which bridges from our internal organization out to this external cloud? How do we transfer data? How do we transfer for work? And so there starts to be companies who are looking at that. So one I mentioned in my talk yesterday, Arjuna, who I happen to do we have some collaboration with them because they're based in Newcastle. So they're trying to build systems which a toolkit which allows you to do this by allowing you to have service agreements between your own internal cloud and an external cloud, and policy engines which allow you to decide what work's allowed to migrate out and when. So I think that at the moment, most uses of clouds are not like grid computing at all, and that's one of the reasons why they've been so successful relatively rapidly, because they've been able to ignore a lot of the hard problems that grid computing had to address. But now we're starting to see these federations of resources, multiple clouds, internal clouds and external clouds. And so all of the work that grid computing did since the early years of this decade should now be applicable and help people to do that.
I don't know if you want to add something to this.
Nothing further.
Well, it's interesting because I was talking with Ken about this subject, about grid and clouds, and he told me that more and more in the States they are not speaking about grids, they are speaking about clouds, because grids really didn't start unless in the high energy physics area. So, but at the same time, researchers in grids have these virtual organizations. They have this trust on the infrastructure. Does this trust exist also for clouds? Are the researchers available to use the clouds? This is something that bothers me. Don't know if you want to comment.
I think in order to build trust, you gotta know what you're trusting, and by its mere entity, a cloud is not something that is easily known. So it's not transparent enough. We can't even agree on a definition. So it's not easy to trust something you can't even define. I guess it's more important of an issue, what is it that you're trusting? What is it that you need? If what you need from that cloud or from that grid is just a result, say supercomputing, you just want a number, you just want a data set, then it doesn't really matter that much, because once you achieve it, you got it, and once you got it, that's all you wanted. So, but if what you're trying to trust, what you're trying to build is dependability, is long-term, is interoperability, it's something mixed with something else, or your systems depend on it, then I think cloud computing just cannot be trusted, definitely, because until we have a clear set of standards, of a clearly defined set of rules of interconnecting, etc., there's no way we're going to be able to trust it. So I think it's a matter of choosing what you're going to do with it. It's just like relationships. Do you trust someone else? Well, it depends. Do you trust them with your life? Do you trust them with your wallet? Or do you trust them with your cup of water? It's not the same thing. So So whether we can trust the cloud, it depends on where we're trusting. It's not something not to be trusted, but it might be something not to be trusted either. So we just got to choose the right tool to do the right job, I guess, at this stage.
You want to comment, Chris?
I can maybe add one more thing, and that is, if you want to be cynical, you can say the trust of the cloud is your credit card number. You get a service, you ask for it, they charge you a credit card number, that's the end of the deal. And I think there are many very nice use cases how people have used clouds, and one of them that struck me particularly is the one from the New York Times. They wanted to index a lot of articles that they had, and so what they did is they uploaded all these files, terabytes, onto the Amazon, and then they run their indexing mechanisms over it, algorithms over it, and in the end, when they were done, they downloaded it. So it was really a huge job they had to do. They did it in record time. They could have never done it on their own hardware. It was a sort of a one-time thing, and there were not really much security or trust issues involved. At the end, they got the results back, those virtual machines disappeared, and that was the end of the story. Now, I can also imagine, for instance, company that want to use the cloud, and they want to put company-sensitive things onto the cloud, they think many, many times over. And they will look into legal issues, they will look into liability issues, compliance issues, and that's where I think these are all issues that eventually can be solved, but we're very far away from it. And I think that's certainly one of the strengths of the clouds, but it's also a weakness.
Mauro Campanella from GAR. One comment and one question. The comment is that I don't think that cloud computing is just nothing new in the technological area. I'm a technician, essentially. I see that cloud computing has been made possible because of new ways of sharing common disk resources. The file system was actually a quite new invention. The CPU is now faster enough to allow a really fast disk sharing. And so is the network. Unless you have these three combined together, you cannot scale to the size of an actual computing center. That was not possible 5 years ago. So I slightly disagree with that. The other technical issue is that cloud computing is only possible when we have almost zero delay. And that is one of the major differences between clouds and grids, is the zero delay, or the speed of light, if you want. It really makes the synchronization extremely tough, and all the protocol is extremely tough on grids, while they are almost, let's say, negligible. Sorry. I will overemphasize my statement so you can comment and shout at me on the grid side. So that was my first comment. I challenge you in saying that there is nothing new technically. I think there is a lot of things new technically. The comment that I would like to receive from you is your vision, which is the interaction between clouds and virtualization. Second comment, one more. I think that there is a profound difference in entering a grid, as it is now, in which you enter an organization, and the way you enter a cloud computing, in which, in principle, you don't enter any organization at all. Every time you create a new one, and then you destroy it. So the paradigm is the opposite. I don't need to enter anything. I just create my own, and then I destroy it. I even create two at the same time. So the flexibility from the user point of view, not talking about the easiness of accessibility, is what really makes the difference between the two different types of organization. Comments? Thanks.
Yeah, I can maybe to the second point. I mean, I mentioned earlier, the grid is the cloud is a grid without the virtual organizations. I think here I would agree with you. To the first comment, I mean, with the delays and the performances, I think in the end people have to look what what the problem is they want to solve, and depending on where the problem is, you may want to choose different architectures, and cloud is one architecture, and it has its strengths and its limitations, and depending on what you do, if you do certain kind of HPC calculation, the cloud would be the wrong platform. You may want to have dedicated hardware that solves your problem much better than a cloud, and in other areas, like, I gave the example of the New York Times indexing, cloud turned out to be the perfect platform for it to be.
You want to comment further this?
Well, I think I largely agree with you. So I agree that from the point of view of the providers of clouds, there's an awful lot of technical innovation that's gone into there, and what I was talking about was what the clouds look like from the point of view of the user, where my opinion is it looks like a big cluster, and we're used to programming big clusters. But obviously building large data centers with tens of thousands, hundreds of thousands of machines, dealing with the dependability issues, dealing with the heat and power issues. We had the excellent talk yesterday from Bill Santanu about the issues to do with that and renewable energy. So I'm sure there's a lot of work by providers to build on technological innovation. In terms of virtualization, then it seems to depend on which cloud you use at the moment as to whether virtualization is seen to be important from the point of view of the user. So, so obviously with Amazon, then what you grab there are virtual machines, the Zen virtual machines, and you can then deploy whatever operating system and software and so on you really need. Microsoft say that they're not building a system that supports virtualization. That's not their intention. They're building a big .NET cloud, basically, and you deploy your .NET applications in it and use the middleware and so on that they provide. So their aim isn't to give you that low-level access that you get with virtual machines so that you could do whatever you wanted with them. They're trying to raise the bar and say, well, if we just focus on .NET, what sort of management and tools can we provide to make it easier for people to build Microsoft-based applications on top of that? And Google are even higher up at the moment, because what they're doing is just to provide an environment in which you can put some code which is executed when somebody sends a message to your web server. So they're right at the top of the stack. And I think the argument for all these different levels is that if you can use as high a level as possible, then it reduces the complexity that's required in order to build scalable applications on cloud-based systems. So if you want to build a web server that's scalable, then you can certainly do that on Amazon by grabbing virtual machines, deploying whatever software you want, deploying systems which monitor the response time to users of your web server, and then dynamically creating new instances of the virtual machines and round-robining the work across those. Or you could use the Google App Engine, and you can just upload the bit of code that's executed when the response comes in and leave it to the platform infrastructure that they provide to do the scaling. So, so my hope is that over time we will start to see higher level platforms in particular domains, in particular niches, which reduce the complexity of building these applications. And at the moment, the three organizations are at different places in that platform level. I think Amazon's right at the bottom, and Microsoft's somewhere in the middle, and at the moment Google's rather high up in one particular domain.
Do we want to raise other questions? I would like to know how many of you are using in your institutions at this moment cloud computing. Okay. And how many of you are considering of using cloud computing in the near future? Okay. And we were talking about this adoption of cloud computing in institutions. And for instance, from my point of view, I'm from a university. I doubt that we will change in a short time the way we offer our services, for instance, to the students. Are we going to maintain the infrastructures, the resources locally and manage them locally? Or are we going to change? I'd like to hear the opinion of the panelists and also of the audience about this issue. What do you think? Are the universities going to, you know very well universities, are the universities going to change in a short period of time?
Well, the last time I talked about a university, I got in trouble big time. So I won't speak about it. I was actually lecturing at a university, lost my job, so I'd rather not talk about that. But I can talk about businesses. I've had several, and I interact with them all the time. Businesses are quite pragmatic. So I'm not saying universities are not, but they're completely different animals. From a business point of view, it's just a matter of security or safety, rather, and return on investment. Now, it's quite clear that from an economic point of view, it doesn't make any sense to have all the resources locally in terms of processing, in terms of, for example, the New York Times example was just perfect. But at the same time, just as we talk about trust and all that, I don't think businesses are going to be jumping on the cloud bandwagon blindfolded. So what I'm seeing from my experience, what's happening is that companies are keeping data locally or a copy of that data and then using the processing of the cloud. So if something goes wrong or if one of the cloud parts providers, whatever, fails or decides to change the data structure or the format or whatever, at least they know that their most valuable resource, which is data, is there, is safe, is safeguarded by themselves. So rather than using or not adopting or not cloud computer, more or less, it's a matter of up to what level. And I think in business it's quite clear. Adopting cloud computing, of course, but keeping the main part or the important part, which is usually data or results locally.
Yeah. What do you think, Christoph?
I think, well, of course I speak with the Swiss universities in mind, so other countries may be different. Overall, I think, universities tend to be organizations that change rather slowly. And it's not just, this is a strength and a weakness at the same time. It's not only that they don't want to change, it can also be they live in a world that doesn't change rapidly, like, for instance, funding models. Different countries have different funding models, and depending on how computing is funded, there may not be a quick change. And obviously, if a researcher wants to use cloud computing, he may have in his table for asking for the grant not the possibility to ask for $1 million to do calculations on a cloud, for instance. I think if you look at the universities, there's sort of two big groups of software. One is the entire administration, the HR part, the student registration, identification, and all that stuff. And I don't think that's going to move to the cloud anytime soon, because the issues, from technical issues down to legal issues, are just way too big. Of course, on the scientific side, I can very well imagine that more and more scientific groups that have specific problems that are very well suited for the cloud may take advantage of that. But again, I also don't think there's going to be a huge change, because universities tend to have computer centers, or they may have contracts with national supercomputer centers, and that's where people calculate. That's where people work. That's how the funding flows. And these sort of things tend not to change very quickly. at least not in Switzerland. Maybe other countries are more dynamic. So I would say on very specific points and issues, I think that's going to happen, and some scientists are going to profit from that because they see a big potential. But a big change, I don't think so in the near future. In the long future, of course, all the bets are off.
So I'm sure people in the audience and some people on the panel know far better than me about the pressures in IT departments in universities. I know talking to people in our own university and other people, including people here, then there's a whole set of pressures which might, over a period of time, lead to the greater use of clouds. So there's the pressures that companies have at the moment with the lack of capital. It's very hard for a CTO or an IT department in a university now to get money to buy new hardware because of the problems of the credit crunch. And yet there's still a lot of pressure from management to do more and more. So in our own university, there's always new management applications that the university is trying to deploy in order to do things like manage our publication records and our citations, because the government's now saying that this will be the basis for funding. So they're always trying to have to quickly put in new applications, but yeah, it's very hard for them to get funding to buy new hardware to do that. So at that level, it's difficult. So the level above, and then you've got underneath, you've got researchers who are starting to, and we're starting to see this, and even students as well who are starting to just go out directly to clouds and use clouds in order to do their work. So I first came across this with Professor Jeffrey Fox from Indiana University, where about a year ago he said that they carefully monitor the students' usage of IT within the university in order to spot those students who are struggling, who are perhaps not attending quite early. And there was a student who they were concerned about because he hadn't used any of the university IT resources on his distributed systems course, and then he handed in a report which was really very good. And when they quizzed him about how he'd done this without using the clusters that they'd provided, it turned out that he'd just gone to Amazon and he'd used the Amazon resources because they were available, and he wanted to play with them. And I'm starting to see that with researchers at my university. So we try to get a feel for what resources they are using and what they need. And we're starting to find people who aren't prepared to wait to get access to machines. They aren't prepared to put in grant proposals which will allow them to buy clusters. They've got a deadline on Friday for a paper. They want to suddenly do some analysis or some reanalysis, and they're just effectively voting with their feet or voting with their credit card. So they're logging on to Amazon or wherever, and grabbing tens of nodes or hundreds of nodes, doing the calculations, and they're prepared to pay the $20, $30, $40 that it costs to do that in order to give them a competitive advantage effectively against other researchers. So there are pressures, I think, from students and researchers coming from below for the IT departments and universities, and also the pressures from above to do more with less resources. And these sorts of pressures, I think, will perhaps lead to these groups to consider seriously using clouds. I think the other thing in my own university, and I guess this is coming in more and more around the world, is the pressure to reduce energy costs and the pressure to be carbon neutral. And again, the talk yesterday was about that and how clouds can actually help with this. So, for example, we as a university have a big condo grid. So we've got about 2,500 machines in this grid, because every student machine, every staff machine, when it's not actually being used, which is true for quite a large fraction of every day, and also, of course, with university vacations, quite a large fraction of the university year. These are turned over and made available to researchers for condos, so researchers can submit jobs and run them. And there's been a lot of that's been very, very successful. Again, it's been a way for researchers to run thousands of jobs overnight or over a weekend. And some people say that there's some people in our university do flood modelling, and they say it used to take them 3 months to do a relatively straightforward sort of model, 3D model of flooding, and now they can do very complex models, lots of different parameters in the course of a weekend. So that's proved very popular. But now we're starting to get under pressure because the university would like to switch off those machines when the students weren't here in order to reduce energy costs and help them towards the carbon neutrality targets that they're signing up for. So with these systems, we're fighting a bit of a rearguard action at the moment, but if these systems start to become unavailable, then again there'll be more pressure to use these external clouds, which are available 24 hours a day, never unavailable, but don't appear on the university's carbon count or their energy costs.
So, comments? Do you want to express your for instance, concerns in adopting cloud computing in your universities? Are there concerns for the universities, for the NERENs that you want to express here? Do you, yes? No. Do you think that your job as IT-related job in the NEREN, for instance, is going to change in the near future because of clouds, or this is not going to happen? What do you think?
To comment, what I've seen happening in my computing center is also that virtualization is being introduced. The reason for that mainly is to spare human effort and to optimize the use of resources. So it's something in between the old model in which we have 200 computers in one. And I see these as a nice step forward towards virtualization. Then it would be much easier to virtualize some of those services outside the university itself. The other things I'm seeing is that as an NRN, I'm putting more functionalities related to computing equipment in the network itself, monitoring, management services, and so on. Those services will never be virtualized or putting in a cloud. The third comment is that if cloud computing is really gaining momentum, not just as computing itself, but also as a natural place in which to distribute information. A Google Center is not just cloud computing, nor is Amazon, is also distributing YouTube movies. Then the network pattern, the traffic pattern in the network will change dramatically. So that will have an implication in the way we have to think the optical footprint of our network. So these are just my thoughts.
Yeah. Yes, please.
So I'm interested in the New York Times example. For a typical commercial cloud, Amazon, for instance, what is the model for moving massive amounts of data in and out of their storage, in and out of their facility where the virtual machines or whatever they are actually operate? Is this within sort of the standard model for these centers? Do they have presence at the neutral exchange points so that you don't have to push this data through commercial networks where you pay metered rates? What is the model for moving large amounts of data in and out of the cloud computing environment?
Well, to the New York Times article, the frank question is I don't know how this works internally. I mean, all I can say from the story that I read is that it was more or less the initiative of the people that actually did that indexing. They felt, well, let's just try it. And they reported that once they uploaded, I think, over 1 terabyte of data, somebody from Amazon came back and sort of checked that this was a real customer here. But how they do it internally, I don't know. Maybe one of you knows.
So my battery just died, so I can't look at the exact figures, but I think they charge you something like 10 cents a gigabyte to transfer data in and out of Amazon.
10 cents per gigabyte?
Yes. So, but wait until my, in case I get sued by Amazon, wait until my computer comes back up and I'll give you the exact figure. But performance isn't great. You know, it's just for most companies standard internet connection. There's no special connections, as far as I know, from particular organisations into these companies. And so just last week, in fact, Amazon introduced a sneakernet facility, so you can post your disks to them, and they will then ingest them into their system. I didn't read anywhere about the reverse, that you could find somewhere to copy the data that you put into Amazon and put it on a disk, and they would post it back to you. So, you know, you can imagine the business model might not want to encourage that, but that's certainly a limitation at the moment. So certainly the sorts of data transfers, the scarily large data transfers you were talking about this morning, Bill, there's no way in which you could consider using those sorts of applications in a commercial cloud at the moment.
Mm-hmm. Yes?
It's just a more generic question. If you drop the cloud or the grid in front of the computing, and you ask an NREN, why wouldn't they, in their well-connected node, provide thousands of computing cores to the national research community? Wouldn't this be a viable business model?
Well, so I'll just confirm there is 10 cents a gigabyte for external data transfer for Google. So both Amazon and Microsoft are very interested in scientific data. So you know, Tony Hayes' group in Microsoft, many of us know Tony Hayes from the grid days. They're keen to talk to people who are interested in putting their data sets and their computations on the Windows Azure cloud. And Amazon have also done quite a lot of work with the scientific community to upload data sets, and almost every week there's another announcement about a new data set, which is now large data sets, which is now available, scientific data set now available on Amazon. And you can understand the business model there. So they make available data sets that attract scientists, and then scientists pay per hour for the CPUs that are used to analyze those data sets. So it makes, you know, hopefully it makes sense to both parties. None of these companies are going to do this as a charitable work, so you can see how they might earn money from that. I think the idea of asking these companies to make resources available to universities, so there's certainly some. There's been some test beds set up. So in the US, Bill, and better than maybe I can't remember. It was Google or Amazon who made a large set of cores available over a period of time to a particular set of universities for free, to try and get people to explore what could be done with those systems. And Microsoft, as I say, are always interested in people starting to explore the systems, and you can usually get a decent amount of CPU hours and a decent amount of storage for free to get you going. As to whether there could be some sort of in the long term, some sort of deal where these companies provided large amounts of resources to researchers, I guess it's a question that researchers and people who purchase compute power on their behalf will have to consider in the future. So rather than if you get a group of people together and they need a certain amount of compute power over a particular amount of time, you have to consider, well, one approach would be to buy that hardware ourselves and manage it and support it in our machine rooms. The other approach would be to go to one of these companies and say, what sort of a deal would you give if we used your resources, assuming those resources were appropriate for what the scientists were trying to do. So I think it's something that will be part of the buying decision-making process in the future.
Do you want to comment also?
Yeah, I mean, I can say what we see in Switzerland. I mean, for those who don't know, Switch is the NREN of Switzerland. We do not offer any resources. The reason for that is that our customers, and that means the universities, they have their own data centers and computers, and we don't want to get into competition with them. They never came to us and said that's something that we want. Now, of course, that's the position today. It may very well change in the future. And one thing, you mentioned the increased cost sensitivity in administration, from the administration side of the educational system. It may very well be that the first universities that want to find other solutions, that don't want to pay for their own smaller cluster because it's too small to really run on a larger scale, they may pool together, and that may very well be a business case for NRENs. And I would personally assume that before individual universities put their data in a large fashion to commercial providers, they would probably rather try to solve it within their own world, either by hooking up with bigger universities or trying to work together with an NREN or a similar organization.
Mm-hmm. But don't you think that there is also the opportunity that the university may consider selling services to other universities? Are this, when they provide this kind of resources, is it possible do you think they will look at this opportunity also?
Well, I wouldn't exclude that. I mean, Switch also charges its customers today, so if Switch does it or somebody else does it, I mean, of course they would try to not do it for free.
So don't you think that the financial model for the universities, and when our management teams look at these opportunities, are they going to change the way the IT is is financed? And even at the European level nowadays, the resources available for education and research have public funds available. Do you think that this is going to change?
Well, I said I wasn't going to speak about universities, but this is a financial issue, so it's an exception. From my experience, which is only mainly Spanish universities, I mean, from the management and all that knowledge, optimization might be an issue, profit might be another. And I don't think Spanish universities see profit as a driving force. They all speak how it should be profitable and they should optimize their resources and everything in the same sentence. And then when it comes to action, they do act towards optimization, but they never do act towards profit because that's business, and they see business as something dirty and something you don't do in the university because you're too cool to do that. So plus there's another point that's quite interesting. There's the political issue. In the university, it's very important not only what it is, but what it looks like and how is it going to be seen. I'm talking about public universities. Yeah. So most deans and heads of IT departments are going to be thinking about how one of their decisions is going to be seen from the outside. And they will come out to the conclusion that if they thought about selling, their part of their processing power or part of their IT department's time or whatever, it might be seen as if they didn't know what to do with it, or if they had overcapacity, or if they weren't managing, or if they weren't in contact enough with researchers that obviously will need that processing power within their university. So they're going to be more concerned about how that decision will be seen rather than how much profit I might make or how it will optimize the resources of the university. So from my limited experience, I think that is quite unlikely. There have been some experiences in Spanish universities, mainly in the Catalonia region, and they've been very small, very limited, and very unsuccessful. They tried to sell some supercomputing power, for example, to companies. They just couldn't find companies that needed supercomputing power. Then they didn't know what business model to use. Then the companies didn't have the knowledge to use that supercomputing power, and eventually it ended up being a big mess. And the media, jumped on it and said they don't know what to do with those supercomputers that cost so much money. And so basically, I think at least Spanish public universities are going to say it's too much hassle and might be an opportunity to make money, but they're going to pass on it, I think.
You have the same opinion?
Well, I think, if they may have a business model for dealing between different universities, that I can imagine, but that a university would enter the commercial marketplace and offer its services, I don't think that's a very realistic thing to happen. For the reason that was mentioned there, it's also, one shouldn't forget that universities in the end, it's public money. And in that sense, one could also ask the question then, if they have money to do that and get more money, then maybe they should get less money and let them not do that. So I think that's, I have trouble to imagine that they would do that.
So a practical problem with that, I think, that we'd have in the UK is the restrictions on what you're allowed to do with networking and machines in universities. So our Janet network has particular restrictions in the UK. I'm sure there's people in the audience who'll correct me if I'm wrong and know far more about it than me. But as I understand it, it's very difficult to get agreement to run commercial traffic over the university network in the UK. And similarly, we get tax breaks when we buy machines for the university, and that means that if we start to use them for commercial purposes, it gets into a very tricky area as far as our accountants are concerned. My own experience recently was that in my talk yesterday, I described this system we've been building, eScience Central, which is an attempt to build a system with cloud computing as the back end, which can be used by scientists in a range of areas. And we developed some of it in a research project, but we got a lot of interest from the Regional Development Authority, who were keen on the idea of whether local companies could use it and whether it could be used to foster collaboration between people in the university and people in those companies. And having looked at some of the issues, we actually bought some machines and hosted them outside the university because of the need to get around these issues to do with whether commercial traffic from companies who are collaborating with people in the university could actually be transmitted over our university networks. So I think it may be not just a matter of the technical issues and what price you could charge, it's also the legal and accounting issues that surround it.
Yeah. Comments? Yeah.
You're talking about the economic driver now. So just before you mentioned also that cloud computing maybe can have a great help on environmental issues. Because it leaves a less bigger footprint when you combine everything. But don't you think that there is maybe a moral obligation for universities or the institutions to take it a step and be quicker, maybe quicker than the commercial world?
So I agree, and there was the excellent talk yesterday by Bill St. Auburn about this exact problem. I mean, you mentioned whether universities should take the moral lead for moral reasons. In my experience, universities are like other organisations, and they often need legislation and some financial incentives in order to take the lead in everything. So, and these are coming in now. We're starting to see energy costs. The university identified energy costs. My own university being a major part of the universities, the money that flows out of the university, looking for ways to reduce that. And then they're also keen on meeting targets that are being set for universities about the amount of carbon that we produce and so on. So I think those drivers will actually cause people to look very closely at outsourcing computing using clouds or other means.
You want to comment? So more questions for the panelists? So we are reaching the time for this panel, but I would like to, before concluding, to hear about the views of the panelists concerning the future of cloud computing. Do you really believe that cloud computing is going to depart and is going to be used in production environments, or it will take a long time to achieve that? Perhaps George and then.
It's tough to use the crystal ball and make predictions, and especially time frames. When will this happen? Will this happen? Stuff. I like to think of cloud computing as just one way of seeing computers and networks. It will evolve, just like I said, this, in my point of view, was an evolution. It will keep evolving, and it might take some new form in the near future, or maybe not the near future, but it will change. What I think it should happen, it might be inevitable, is that it's going to permeate every area of our daily life, every gadget, data is going to be all over. It's going to be connected, and it better integrate well. Imagine a world where electricity had different versions: electricity 1.0, electricity 3.6, and they couldn't talk to each other. And you like turn a switch, and it didn't come on, and then the electrician said, "Well, but you're using an outdated bulb, and it's not going to work today. But maybe if you update it tomorrow." And it doesn't make sense, and that's what's happening in networks and computers today. We cannot imagine a world where you turn the tap on and the water doesn't come out. There's a network there. There's something that goes through the network, the pipes. You pay for it. You use it. Everybody's happy, more or less. There are several companies there that you sharing that network. The basic elements are the same, but the usage is just transparent. In order to be transparent, there are many things to be agreed on. Well, I think that's what's happening with computers, with networks, and with cloud computing in this case. It's the beginning, although we've said it's been here for decades. But if you take a step back and see it from a distance, it's the beginning. And in order for it to become something really useful and really part of everything, it's got to be, there are many things that got to be agreed on, and many things that still got to be built. Otherwise, we're going to end up being frustrated with it. Or what's happening today is that things are evolving so fast that we don't stop and agree on anything. We just new things and new versions and new things coming out, and then we adapt and we change, and that's great. I'm the #1 fan of advancement and modernization and all that, but at some point we should think about, HTML. If you think about it, it's quite ridiculous. HTML is quite dumb. And then it was awesome. It was great, just because, not 100% standards, W3C and stuff, but it's such a breakthrough because we almost agreed on it. So I think it's the same thing with cloud computing. What will happen with it? It will evolve. We better agree on some things that got to be discussed. And if it's got to be useful, it's got to be transparent. Otherwise, we're going to have to come up with something else.
Well, I think there's definitely, cloud computing definitely has its place in the future. But I would also like to add a caveat. I mean, it is a buzzword right now. People are very enthusiastic. And I think it also shows great promise. So there's reason for being enthusiastic about it. But I think it will have a future, but it may not be the future that enthusiasts see today. I think not all applications are suited, not all IT environments are suited. There will be, of course, areas where cloud computing is the right thing. However, I think there's also sort of two things that I think one should not forget. The first one is, today as it is, it's really a vendor lock-in. I don't think big companies or universities will move in the long run in a big way onto the cloud as long as it means I write my code, my environment for a specific provider. There has to be standards, and there has to be a move away from the vendor lock-in that we currently have. I mean, I think no CIO would dedicate a big development effort spending several $1 million and then only have Amazon as a potential provider in the future. I think people will be very, very hesitant to do that. So we need those standards. And the second one is, I think also in the university sector there's definitely a place, but I wouldn't be surprised if in the end the cloud provider is not a commercial company, but universities organize themselves in one way or another.
Well, I think that at the moment what we're seeing is the people who are using clouds, they're using it where it's what you might call low-hanging fruit, so for either technical reasons or business reasons. So business reasons would be, for example, startups where they don't really have any choice. They don't have the capital which will allow them to buy large amounts of service to meet the potential demand of their company. And for technical reasons, then we're seeing it being used successfully for very scalable, highly parallel sorts of applications, like the New York Times example there. And so I think we'll then move on to start and think about the harder challenges. And as usual, this always lags behind. There's always some enthusiasts who feel everything's really easy and simple, and they do the simple things, and they are easy to do. But then you've got the hardcore distributed systems people who have to move in afterwards and start to deal with the real problems which need to be solved if a larger class of applications are to be able to move on to clouds. And that will cover things like dependability. How do we build dependable systems, given that at the moment clouds sometimes go down for 2 or 3 hours? How do we deal with the security issues of moving data around from organizations into clouds? How do we avoid lock-in, which has already been mentioned? So one way to address that is standards. The other way is to have flexible ways whereby software can be deployed in more than one vendor's cloud. And I think looking at the short term, so the next couple of years, then I think private clouds, so this isn't a particularly controversial thing. I think Gartner said that the main driver for cloud computing will be private clouds over the next few years. So companies thinking about, well, it's so easy just to go to Amazon and grab resources when I need them for my application, scale them up and down. Why can't I do that with my internal IT? And so we'll start to see some of the principles of from external clouds coming into place within organizations, and clearly virtualization is one step on the way towards that. And then as soon as we've got that, there'll be the federation, which I see as being the key thing, and this is where clouds start to look more like grids, where people want to have their internal clouds but want to be able to seamlessly move work from them when those internal clouds are running out of power out to external cloud providers for a while until the extra load has been dealt with, and then perhaps contracting back to the internal clouds afterwards. So I see lots of interesting technical issues that need to be addressed, some of which can build on earlier work in distributed computing, and some of which I think are unresolved problems which need to be addressed.
I think we will leave this session with lots of issues to think about in terms of cloud computing. So I would like that we thank the panelists for sharing with us their expertise in this area, and tomorrow we will be continuing to hear about cloud computing in the plenary session. So thank you very much for being with us.